Explain why this is an improper integral, and it's simply because the upper limit is infinite. That's all we need to say here. Now we're asked to basically find the integral, show that it's equal to k pi, where k is a constant to be determined. You don't need to do any sort of substitution here. You need to recognize the kind of formula, kind of integral it is, and take a look in the formula book. And here it is. Here's our result. If you integrate this, then you get 1 over a arctan x over a. To do this integral, I know we're not quite in the right form at the moment, but what you would actually do is a substitution, x equals a tan u. Make sure you can do that. Follow through the steps. This is on A-level maths. Worth practicing from time to time, trig substitution. So in our case, right, there's two ways we can deal with this, and I'm going to talk about both. The way that I did it is I thought I want to get rid of the 9 because I want an x squared here. So I'm going to actually factorize out a 9 from the bottom. So it'll become the integral between 4 over 3 infinity of 1 over 9 x squared plus 16 over 9. And then I can actually bring that 9 out. It's going to be 1 over 9 times the integral 4 over 3 infinity 1 over, and then 16 over 9 is actually 4 over 3 squared. So let's write it in the same form as here. 4 over 3 squared plus x squared. Now, before I do the integral, just need to deal with the improper aspect correctly. And what we do is we bring in a limit. We say the limit as a, oh, do I want to use a here? Probably not, because I've already used a in the formula. So let's say b. The limit as b approaches infinity of the integral 4 over 3 b. Right, that's better. Okay, now we can do the integral, and we're going to get 1 over 4 over 3. So that's actually going to become 3 over 4. Then it will be inverse tan of x, again, over 4 over 3. So it's going to be 3 over 4x, or 3x over 4. And our limits are going to be b and 4 over 3. And I'm going to keep going before I talk about the second method. So right now I can do 1 over 9 times 3 over 4. Actually, that's going to become 1 over 12. I can bring that 3 over 4 out to the limit. So I will get inverse tan of 3b over 4 minus inverse tan of 1. Now we just got to think, what happens to inverse tan as b approaches infinity? And you might know what inverse tan looks like. It's actually like this. Since tan approaches infinity as x approaches pi over 2, the opposite is true. As inverse tan approaches infinity, sorry, as x approaches infinity, inverse tan approaches pi over 2. It's an asymptote. And so in the limit, we can say that it will equal pi over 2. And then inverse tan of 1 is just pi over 4. This becomes pi over 4 inside the bracket, so 1 over 12 times pi over 4 gives us pi over 48, or 1 over 48 pi, because we're asked to leave it in the form k pi. And there we have it. We've worked out this integral. Now, I did say about another way of doing it, and I want to talk about this. So instead of taking a 1 over 9 out, there's a slightly different approach. And that is, okay, I'm not going to worry about the limits here, just to illustrate the idea. So we've got 4 over 3. What I mean is I'm not going to worry about this bit. Right, now this time I'm going to try and get it like directly in this form. So I could write it as 4 squared plus 3x all squared if I wanted. And now it's kind of in this form. We just have to do one little thing on top of what we were normally doing. So it's going to be 1 over a, that's 1 over 4, and then inverse tan of x over a, well, my x is actually 3x. Sorry, I should have said that my a is equal to 4. So then it's going to become 3x over 4. Now, this is not quite the same as what we got over here because we got like a 1 over 12. And the reason for that is that we also have to divide through by 3. Because when you differentiate this back, you would deal with the outside, the inverse tan, but then you would times by the derivative of the inside, and you'd end up timesing through by 3. So that is why we can basically use this. We can replace x by 3x, but we must then divide by 3 after. Just in the same way that if you integrated 2x plus 1 to the 7, you would raise the power by 1 and divide by the new power. So we'd be dividing by 8. But then we also have to divide by 2, because when you differentiate it back using the chain rule, you would times by that 2. Same idea. So it's up to you which route you go. Just be careful if you go in this route on the right. Of course, you might say, yeah, just practice it. It's easy. It's always quite safe to just think, right, if I differentiated it back, what would happen? What would I times by? And in our method on the left, it kind of all worked out, because the 3 times by the 3 would cancel out partially. But yeah, here you just got to make sure you're bringing it in. That's what I'm trying to say here. Well done.